Binary numbers. It's an important chapter, short, easy chapter. It's like it's offering free numbers, free marks. One question for sure. It's a pattern, not for sure. The thing is sure. So binary numbers. Till now, which kind of numbers do we know? Decimal numbers only. Decimal numbers are made up of digits from 0 to 9. How many digits are this? 9 or 10 or 11 or 8?
10.
10. These are 10 digits, and using which we formulate our numbers. So like after, for like filling a number, for counting, like consider this is an apple, orange, which are circular. 3 orange, 4 orange, 5 orange, 6 orange, 7 orange, 8 orange, 9 orange. Now after 9 oranges, to count the next orange, which is this, to count this orange, we have to use 2 places for any and that particular number, because after 9 was like single digit number, but now we have to use 2 digits. Why it is so? Because we have only 10 digits, and we have utilized 0, 1, 2, 3 every digit. Now there's no another digit left. Okay, understood? That's why we have to use second digit, the second place, the left place. Okay.
Yes, sir.
So in number system, it was like this. This is the place ones. This is tens, hundreds, thousands, 10,000s. So ones means that we are considering the digit itself as a number. So if I write 2 only, so this number is 2 only. But if I write anything like it's getting multiplied, 1 is getting multiplied to 2. 1 is actually, let's see, what is 10? 10 is 10. What is 100? 10 raised to power 2. What is 1000? 10 raised to power 3. What is 10,000? 10 raised to power 4. 10 raised to power 5. So on and on and on. Okay. So this is basically 10 raised to power 0. So that's how we make a decimal number system. Okay.
Yes, sir.
Our whatever numbers we have discussed till yet, and we have been studying from class nursery, like 1 apple, 2 apple, 3 apple, 4 apple, 5 apple, 6, 7, 8, 9, and then for counting it further, we use 2 digits and write it as 1 0. So 0 is having no significance here. 1 is having significance of tens. So 1 tens, 0 ones. So this can be written as 1 tens and 0 ones, right? And if we have another orange, then it is 1 tens and 1 ones. Clear? So this is how decimal numbers are there. So now we can figure out that to add any 2 numbers, we have to take carry after 10. Like if we run out of digits, then we have to use the second place. So 9 plus 2. So 9 is the utmost, like the maximum single digit number is what? We are talking about only decimal number system right now. Tell me, what is maximum single digit number?
9.
Yes. Now this one will. Now Tanish, tell me, what is minimum single digit number?
0.
Wow. You have won 10 crores in KBC. Anyways, so this is the concept. So we can like have ones place maximum number as 9. So after 9, we have to take carry and use this next place. So that's why after we have, we cannot write 10 on a single place. So after 10, we have to write it on the next place. So 9 plus 2 becomes 11. That's why. So my basic thing is, my point is that after 9, we have to use the next place. But what if I ask you and we use the same logic? If we have only two numbers, that is binary means two, number mean two. And which binary numbers? 0 and 1 only. What if we have 0 and 1 only? So we have to take carry after two number itself. So if we have to write, let's say, if there are, let me first draw a space. So this is a space. So in this is a particular box. Okay, this box is having no oranges. So how will I use binary numbers to represent? Let me write number of oranges in the box. So how many are there? How many oranges are there in the box? Can you see any?
0.
Yep, 0, which is a binary number. So no problem denoting it. What if I say no? There is a orange which is now in this box. Okay. So this is the orange consider. Now how many oranges are in this box? Using this two digits, you have to tell me. How many oranges are there in the box?
1.
Yes. But problem starts coming when I insert another orange in the box. Now how many oranges are there? How can you use these two numbers and tell me how many oranges are there? Is there any option where you can tell a single digit and tell me how many oranges are there using these two numbers only?
No,
Is
sir.
it possible to do? No, right?
No, sir.
Using a single place digit, like a single digit, we cannot now tell ki there are how many oranges in this box using these two digits only. So now we have to use another place in this binary number system. Okay, so earlier what we were doing, we were discussing about 10 raised to power 0 because we had 10 digits. So now logically we have two digits, like two digits. So this should be 2 raised to power 0 and this should be 2 raised to power 1. And the next place should be 2 raised to power 2. Understood that why it is happening so and how have I written? What is the logic behind?
Yes, sir.
Yep. So 2 raised to power 0. So 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. So now what we were doing earlier, like to write 111 oranges in decimal number system. So we were writing 100 plus 11 plus 1. So if we further think of it, so we were writing one hundreds and okay, done a mistake here. What we were doing? 0 plus 1. 1 tens and 1 ones, right? So what we were doing basically, we were breaking down the sum in 10 raised to power 2, 10 raised to power 1 and 10 raised to power 0. And even if it higher exponents, if it is required to do so, right? So now to do the same for the binary number system, let's try to write this particular two oranges binary system. So one raised okay, so these are the multiples that we have to use. So is there any direct multiple that we can use here to write two, like 1 into, if we take 1 into 2 raised to power 0 and then remaining one is remaining na, then we cannot take any other digits because we have to only write the natural number here. No, not natural. Only these binary numbers here, 0 or 1. So if we write 1 into 2, then 1 is left, and we cannot make 1 further on, because further on there is always 2. So to make this particular odd number, we have to take 2 raised power 0 as 0. So we have to uh, multiply 2 raised power 0 as 2. And now what is left? 2 itself is remaining. So what number should be multiplied to 2 to get 2? Like my question is simple. So we have multiplied 0 here. So that because our number, this number that we have to represent in binary is is even. That's why we have taken 0 here. Okay, so that's 0 here. And now what should I multiply here to get the remaining, which is 2? What should I multiply here?
2.
0, 1, 2. What?
2.
Okay, so if 2 gets multiplied by 2, what will be the answer?
2 into 2 means it's 4.
Huh?
But
So
it's 2 raised to power 1. Oh, okay. Sorry, sir. 1.
yeah, 1.
Writing
So
is
here the places, my point is the places should be filled by only 1 and 0, so that we can get our answer. So basically, if we write 1 0, so in binary this is equivalent to 2 in decimal system, because there are 2 oranges. Clear? There were 2 oranges, so this is 1 0. Okay. I don't know what I have done. So any doubts? How have I written so? So this is just an introduction of binary number system, that what is happening and why it is happening. Now I'll be giving you techniques, particular techniques. You will be able to convert any decimal number into binary number very easily. So my point is that in decimal system, in decimal number system, when we write place values, ones, tens, hundreds, the base is 10 and the power is increasing. And it is the same for binary numbers also. But the base right now is 2. The power is increasing, but the base right now is 2. So this is the concept of binary number system. And I'm also trying a change in my classes, that I am not going to bring PPT, pre-prepared PPT. I'm just going to come with blank slides and derive whole of the concepts here itself, so that uh, I'm just trying it, and we'll take feedback and review at the end of the class. Okay.
yes, sir.
Yeah. So is this clear, that how binary number system is different from decimal number system?
Yes, sir.
Okay, so I'm writing something, and you just have to see and observe that how I am doing so. So first of all, a binary number system starts from 2 raised power 0, 2 raised power 1, okay, and 2 raised power 2, 2 raised power 3. It goes on and on, okay. And if it is going in this direction, if power is increasing, then the power may also be negative sometimes. And when it will happen, I'll cover later in the.
This the negative will be going in the right side, sir.
Yes, in this particular system, because we write decimal digits on the right hand side of the number. That's why I have written it so.
Okay,
Okay.
sir.
Prakash. Okay. So now let me write 1000. No, 10,010. Okay. This is in decimal number system. Now in decimal number system, how have I written it? Like 10 raised power 4 and then plus 10 raised power 1. Okay, but now let's discuss about what multiples of these powers, let's say uh, whatever power we will require, any power and any power of 2 to any power of 2. So how this can be written in the multiple of 2's power, and then we'll be able to find out its binary number. Okay, so if we find out, so how do we particularly find out in a particular technique, so that we'll be able to convert any conversion of decimal. Let me place my pen tab correct. Of decimal number to binary number. Okay, so for doing so, first of all, you have to understand one thing, that everything, like all the places, let me go back. All the numbers are the multiples of 2. Okay, if we look on this side, so only odd number is this 1. So to make any number odd, the leftmost, the sorry, rightmost place digit will be 2 raised to power 1. So that has to be 1 to make any number odd. So let me go back and go back to the technique. So let me, I'm taking an example, and by this example, understand that let us say 175 is a decimal, is a number in decimal number system. Now we have to find out its binary, its number equivalent number in binary number system. Okay. So for finding 175, so we will write 175 like this, and this is known to us, but in this technique we are drawing one more line, so be aware. So first of all, we have to multiply it all the time by 2, but it's not getting multiplied. So what we are going to do is that we will write 1 here. Why 1 here? This 1 represents that we have subtracted 175 from 1, and whatever is remaining 174, and we are dividing the remainder. So 174 divided by 2, it becomes what? 287, 87. Okay, 87 it becomes. So now further, we have to multiply the whatever the remaining remainder is, whatever the quotient here is, we have to keep on dividing it by 2 only. So 87 is also an odd number, right? Is that correct? So we will subtract 1 from 87, it will become 86, and then we will divide it by 2. So what will be the answer? Please keep on responding so that I feel
Um,
students are listening. Yeah. So again, this is an odd number, right?
yes, sir.
So we are always going to divide it by 2. So for doing, we have to subtract 1. So after subtracting 1 from 43, it becomes 42 divided by 2. What is that? What is this? What is the question? What is the answer for this division? What is 42 divided by 2?
21.
Okay, good. So 21 is still an odd number. So dividing. Now 20 by 2 becomes 10. Now this is an even number, so we will not subtract anything. Now this is an odd number. So 4 by 2, 2. Now this is an even number. So we are not going to subtract anything. 1 is left. So 1 will not get divided by 2. So it our process tab stop, what should stops here itself, and our answer is this for this particular question. And in the same manner that I have highlighted it to be. Okay, so now for writing 175 in binary number system, we are going to start from the bottom. So we'll write 1 first, then 0, then 1, 1, then 0, then 1, then 0. Okay, then 1, then 1, then 1, then 1. So rechecking. Okay, this one fine. So this is the binary number format for this particular given decimal number. Okay, clear? Any doubts? Any doubts?
No, sir.
Good. So let's take one more example, and please understand it clearly. This is a very easy chapter, and now we have to change this decimal number in binary number system format, and write 53 here. So this is an odd number, will not get divided by 2 easily. So we have to subtract 1. So 52 by 2 becomes 26, which is an even number, nothing to subtract. This is an odd number. So 12 by 2, 6. This 0, we do not have to subtract anything from 6. So 6 by 2, 3. Now we have to subtract 1 from 3. 2 by 2 becomes 1. So whenever 1 comes, we'll stop. Our answer is 11011. We will write it 110101. So 110101. So this is 53 in binary number system format. Any doubts?
No, sir.
Great. So what if there is a number like this, 53.25? Then there's a problem, right? How can we write a decimal number in binary number system format, which is having its point? So for doing this, simply first do this. Like 53 can be written as 53 plus 0.25, right? So first convert 53 into binary number system, which we have already done, which is 11001. So this is in binary number format. Let's convert 0.25 now. Okay. So for doing this, we are simply going to write 0.25 as a here, and write binary here. So simply what we are going to do is that we are going to multiply this number by which number? 2. Okay. So we are going to multiply this particular given number by 2. What is the answer? What will be its product? Come on, tell.
0.50.
0.50. Now we are going to take this place, this particular number, and we are going to copy this and paste it here, registry. Okay. So now let's take what we have to take only the number after points. So we'll take 0.50 and we'll apply 0 naturally here. Multiply again by 2. What is left? What should be the answer? 001. Agree? Yes.
Yes,
So
sir.
now we are going to take this 1 and paste it into our registry system. So we have registered it in our entries. Now we are only going to consider the points after this. So this becomes 0 naturally before the point, and whatever was there after the points, this was 0 0 only. So this sum ends here because it is 0. So this is end, this ends here. So now how we can write 0.25 in binary number system is that we will write 0.01 in this format. 01. This is how we will write a fraction, decimal to binary. Clear?
Yes.
Clear? Any doubts? No. Okay. If no doubts, let's understand all the things from a reverse engineering method. So what all examples that we have discussed, that's for 175, we have calculated that this is the binary number. What if we had not known that 175 is the decimal number? So let's find out a question. Let's make a question for ourselves, and we have to find out what is the number. 1010 1010 11 11. Okay, there's a mistake. 2 must be here. Okay, this is a binary number. So this is a binary number. We have to find out its equivalent in decimal number system format. So for doing that, I have already covered this also. So as this place is ones place, so 2 raised power 0, 2 raised power 0 place, 2 raised power 1 place, 2 raised power 2 place, 2 raised power 3 place, 2 raised power 4 place, 2 raised power 5, 2 raised power 6, 2 raised power 7. Simply do nothing but just multiply these. So first write there, what is their value? What is 2 raised power 0? What is 2 raised power 0?
1.
Yes, good. 2 raised power 1?
2.
2 raised power 1. What is this?
2.
2. 2 only, na? 2. What is 2 raised power 2?
4.
8, 16, 32, 64. This should be 128. So we are going to do nothing, just multiplication of this and this, this and this, this and this, respectively. We are going to multiply all of this, and after multiplying, we are going to sum it. Okay. So 128 into 1 becomes 128 only. 64 into 0 plus 32 into 1 plus 16 into 0 plus 8 into 1 and 4 into 1 plus 2 into 1 plus 1 into 1. Okay. So let's calculate. Help me calculate. 128 into 1. So 128 becomes this. This becomes 0. 32 becomes 0 plus 8. 4 plus 2 plus 1. Okay. Please help me when I do any calculation. Let's say 2, 4 becomes 12, 12, 3. This becomes 15.
75.
Yeah. 15 and 32 becomes 47. Now this becomes 8, 7, 5, 1 carry, 12, 4, 16, 16 and 1 carry, 175. Should be a decimal number. Is that correct? Yes, it is. Clear? Any doubts? Yeah. So let's do this for this time. 53.25. So 53.25. No, we're not taking 532.25 this time. You have to find out this. Using what? Oh, I have forgotten to write the answer here. So 53.25 in decimal number system is represented as this. This was for 53 and plus 0.01, and we'll write 0.01. So this is our binary answer. Now we have to find out for the same. 110101 and 0.01. This is the given binary number of which equivalent we have to find out in decimal number system. So we will do the same, right? So 1,1,0,1,0,1.01. So this is 2 raised power. Come on, speak. This is what 2 raised power 0,
0.
1, 2, 3, 4.
4. 5.
After point, the power is going to decrease. Okay, so we'll multiply same. So first of all, let's write their values. What is this? 2 raised power 0. What is 2 raised power 0?
1.
2, 4, 8, 16, 32. 1 by 2, 1 by 4. Okay. So multiplying 32 into 1, 16 into 1, 8 into 0 becomes 0, 4 into 1 becomes 4, 2 into 0 becomes 0, 1 into 1 becomes 1, and 1 by 2 into 0 becomes 0, and 1 by 4 into 1 becomes 1 by 4. Okay, so help me calculate. 20 and 21 and 21 and this 53 plus 1 by 4. Now 53 plus 1 by 4 we know is 0.25. So this becomes 53.25 in decimal number system. Is there any doubt for conversion? This is what we are discussing right now, is conversion of binary number to decimal. Clear? So this is all the chapter is. Okay. Any doubts, anyone?
No, sir.
Okay. So give me a number. I'll do the job for you. Just any number you speak, any decimal number or binary number, whichever you may like. Come on, speak. Any number.
Any number. Decimal, no, sir.
Hmm.
1011.
Okay, this is decimal number, right? Okay.
1011. 0.1. Okay.
Okay, point
0.10.
10. Okay. So this is in decimal number system, and I have to find out the equivalent for the same in binary number system, right? Yeah, is this the question?
Yes, sir.
Okay, great. So first of all, what we have to do, we have to take this number separatively and find out for the binary equivalent and this separatively. Okay, so let's do this for first. So this is not going to get complete divided by 2. So for that, we'll have to subtract 1 from this. So 1010 divided by 2 becomes 505. Now this is also an odd number. We have to subtract 1. 504 divided by 2, 252. This is an even number. We do not have to subtract anything. So this becomes, this is also an even number. This is an odd number now. 62 by 2 becomes 31. Odd number 30 by 2, 15. Odd number 14 by 2, 7. Odd number 7 minus 1, 6. 6 by 2, 3. 1. 2 by 2 becomes 1. So the equivalent for this decimal number in a binary is 1 we also have to count this one. Don't forget. 1, how many ones are there? 2, 3, 4, 5, 6. Okay. 0, 0 and 1, 1. This is the binary equivalent. If I have done any mistake in calculation, please correct me. Let's now discuss about this. So 0.010 into 2 becomes 0.20. And in our registry, we will write this digit 0. Now we will take 0.20 and apply 0 ahead, multiplied by 2, 0.40. Okay, we'll take this registry and 0.40 to 2, 0.80, 0, and we'll write 0.80 and apply 0 here. 2 becomes 1.60. So we'll write 1 here and we'll take the 0.60 and we'll apply 2 by ourselves. This becomes 3. This becomes 1.20, right? Taking 1 here and 0.20 and then go ahead. And also we know that just calculate for 4 binary digits. That's more than enough to find precise calculation. So the binary equivalent for the same is we are going to take the observations from top to bottom in this time. So 0.00 three zeros and 2 ones. So adding these two, 1 1 1 0 0, what was that? 0 0 and 1 1 point 3 zeros and 2 ones. So this is the binary equivalent for what the number was given to us. Now let's recheck it. Let me recheck it using AI to save our time. I'm going to ask. Let me screen share the AI screen first. Copilot. There's also one more small topic left in binary numbers, which we are going to cover in this class only. So, is the screen visible?
Mm, yes, sir.
Okay. What was your answer? 3 ones, 2 zeros, 2 ones, and then point 3 zeros, 2 ones. It's fine. So that is, don't teach us, I'm a teacher. So that is 115. Okay. So let me see if I have done any mistake. I've done a mistake in typing this. Let's go back to our screens to understand what was the mistake. In typing this. So, see, what was your answer? What was your answer? This was your answer, right? Oh, 3 ones, 3 ones, 2 zeros, and then 2 ones, and 3 zeros and 2 ones. And what I have typed here, what I have written here is 3 ones only. There has to be 6 ones. So now is it correct, right? As per our calculation? Hana?
Yes, sir.
Yeah. So let's go back to the AI screen. Okay. So saving time. Hmm. 3 ones. So, okay. Show me the answer. Yes. So the answer here is So the answer here is 1011.09359375. Now, what was the number given by Yarini to me was 1011.01. And there is a slight difference in this because we considered only the 3 zeros and these 5 digits from the decimal place. That's why it
I
is rounded off. It's correct. Okay. Yes. You speaking something?
actually I gave that 1011.10. Right?
Okay. 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 Let me see. Yeah. Yeah. Okay. 1011.10 was the number given to me.
Ah.
Hmm. Yes, you are right. So, okay. Okay. I'm doing a mistake here. I was. So is the screen visible? So what I was doing is I was rounding it off to this, but that's not correct because you cannot make 9 to 1. We will write 10 here itself other than 9. Okay. Clear? Any doubts?
No, sir.
Uh, so our answer is correct when we round off this. And why we are not exactly correct? Because we have only considered few digits for the binary registry, right? And we'll do the same in questions also. But that will depend on the given options because uh, sometimes we'll have 5 digits after the point, after the decimal. So if we have 5 digits after decimal, we have to solve 5 steps further when we are converting a decimal fraction into binary fraction. Okay. Okay. So be conscious while looking at the question. Clear? Any doubts?
No doubt, sir.
Okay. Okay. So there's a single very short concept which is asked in PYQs, which has been asked by the UPSC. So in this, if you have to find out, the question will be like, what is the first or primary complement of this binary number? Okay. Question will be like this. And all you have to do, all you have to do is conversion. Is conversion. How will you write the answer? Simply write 0 at the place of 1 and 1 at the place of 0. So 1 will be replaced by 0, 0 will be replaced by 1, 1 will be replaced by 0. So this is the complement, the first complement of this given binary number. Okay, clear? Simple, this is the answer. Clear?
Yes, sir.
So if this is the binary number, its first complement will be 3, then 3. Simple, as simple as that. Okay, clear?
Yes, sir.
Let's discuss algebra for binary numbers. So it's simple. As you were discussing about it earlier also, that in decimal system, we used to change the place, take the next place after 10. After we have used all the 10 digits. Now in this time, if we have used both of the digits 0 and 1, now we have to use the next place. So simple, if you write 0 plus 0, then it will be 0. If we will write 0, 1, so it will be 1 simply. If we will write a 1 plus 0, so it's 1. So it's basically commutative. Okay, let me write it properly. And if we have to add 1 plus 1, so now this is 2, which is not there in the binary. The 2 number is not in binary. So write 2 after converting it to binary number system. So 1 0 will be our answer. So 1 1 will become 0, and the remaining will go to the next place as 1 as carry. Okay, this is carry. So 1 plus 0 is 0 with carrying 1 to the next place. Any doubts?
No doubts.
Any doubt? No doubt. Let's take an example. 1011 is a binary number getting added to 1001. Okay. So if 1 gets added to 1, it becomes 0 with 1 carried to the next place. If 1 gets added to if 1 gets added to 0, it becomes 1, and then further 1 gets added to 1, which is the carry. So it will become 0 with carry to the next place. 1 plus 0 becomes 1. 1 plus 0 becomes 1. 1 plus 1 becomes 0 with the carry 1 to the next place, which is 1 plus nothing becomes 1. So this is the answer. Clear? Any doubt? Any doubt?
No doubt, sir.
Yeah, so verifying this was in binary number system. Let's write for decimal number system for verification purposes only. So this is what? This is 2 raised power 0. This is, let me write it in a different color. So what we are doing now is that we are converting the given binary numbers in decimal number system to verify our addition. So this is what? 1, that is 2 raised power 0, then 2, then 4, then 8. Same goes for that. So 1. So let's write 8 plus 3. 8 plus 2 plus 1 becomes 11, right? 8 plus 1 becomes 9. This should be 20. Now let's check for this. 16. So 16 plus 4 becomes 20. So yes, this is 20. So is our addition simplified and verified by decimal number system? Clear? Any doubts?
No doubts, sir.
Okay. Let's now discuss about subtraction. So if we subtract 0 from 0, what remains 0 is only. If we subtract 1 from 0, it remains 1 only. If we subtract 1 from 1, it becomes 0 only. But if we subtract 0 from 1, then it's going to remain as 0 with, you know what? With uh with 1 as, like, it's not carried, it will be borrowed. Because what is actually happening is 0 is becoming 1 after borrowing 1 from the next place with debt of debt of 1 from next place. So this is the concept. Any doubts? Any doubts?
No doubts, sir.
Let's take an example to better understand it. 10001 subtracted by 10011. Okay. Okay, so but we cannot subtract it like this. Clearly, this the above figure is greater than the lower one. I've spoken positively. Anyway, so this is the subtraction. 1 gets subtracted by 1 becomes 0. 1 gets subtracted by 0 becomes 1. This is becoming easy. But maybe it will become a bigger number then. Okay, let's do this now first. One gets subtracted by this becomes 0, 1, 0, 0, 0, 0, 1 minus 1, 0. So this is the answer. Sorry. 1 gets subtracted by 1, 0 becomes 1. So let's verify this. 1, 2, 4 doesn't matter. So this is 2 in decimal. 16 plus 3, 19. 16 once so this is 17. So yes, this is correct. Clear? Any doubts?
No doubt, sir.
Doubts? Yeah. And if you face any difficulty doing this, so simply convert them into decimal number system and then find out the answer and then convert back this into binary and mark the answer, mark the option. Okay. Okay.
Yes, sir.
Yeah. But I'll recommend you to understand the concept because it's also important. Let's now discuss about multiplication. So if we multiply 0 by 0 becomes 0, 0 by 1 becomes 0, multiply 1 by 0 becomes 0, multiply 1 by 1 becomes 1. Simple as that. Any doubts? 1 into 1, 1, 1, 0, 1, 1, 0, 1, 1, 0. So 0, 1 becomes 1, 1, 0 becomes, we are adding here, na? So this is our answer. Let's convert it. So 1, 2, 4. We are converting now this into decimal number system. 4, 5, 1 and 2, 1 becomes 3, which should be 15. So this should be 15. Let's check. So 8, 4, 12, 12, 3, 15. Yes, it is correct. Any doubts? Any doubts?
No, sir.
Same concept. Okay. Let's take an example directly because we have already discussed about the concepts earlier. There is no new concept. So if we have to divide by 11, so 101 can be get divided by 11 by 1. So no. Subtraction. So 1 divided by 1 becomes 0. Now, now there is a good example of subtraction. So 0 cannot be get subtracted by 1. So this has to become a greater number. So for becoming this as greater, this will become 1 and 1 will be get borrowed by the next place. So 1 minus 1 becomes 0 and this was borrowed. So this became 0. So it is nothing. So let's take the next digit now down. So this becomes 0, 0, 1. Okay. So now let's see. We have taken 1 by 1 minus 1. This will become 0. Okay, correct. Okay. Let's see if I have done any mistake or not. This is 1 cannot get subtracted by 10 because 10 no 1 0 which is actually 2 in the decimal number system and this is basically 3, so no. So we had to take the first 3 digits, we have multiplied it by 1, so 11 into 1 becomes 11 only, like 1 only. Sorry for my incorrect narration. Okay, you have to pronunciate it as 1 in binary. Okay, so 1 gets subtracted from 1 becomes 0, then 0 cannot be get subtracted, so it has to be 0 0 1 on. So now if we discuss it further, so can it get further uh, multiplied by like any multiple of 11 can become this 1? Do you think so? Do you think so? No, because 1 itself is less, so this is the whole multiplication, but there was no point because these two numbers, let's write this as 90 multiplied by 2, so 45 will be the answer. Okay, so my suggestion to you for division or any other algebraic operation in which you are facing any difficulty, convert the binary first to decimal, then solve it, then the answer converted back to the binary number system. Okay, clear? Any doubts?
No,
Any
sir.
doubt? Addition subtraction is mostly asked, and if multiplication division is there, then convert them to the decimal number system. Now we're discussing about first complement of binary number. So let's discuss about seconds complement of binary number. In this, we do not have to do anything other than addition of 1. Okay, what? That first of all, whatever the number is given to us, let's say this is the number given to us, we have to find out its complement. So first step, find one's complement. Okay, so one's complement of this number is 0 1 0 0. This is the one's complement. Second step is add simply 1. Add 1. So if we add 0 1 0 0 and 2 1, so 1 0 becomes 1 0 becomes 1 only. 0, this is the remaining. So the second complement of 1011 is 101 simply. This binary number. This is the answer. Any doubts? Any doubts?
No, sir.
Yeah, so this is the chapter binary number completed. Okay. Yeah, solve the questions, solve previous year questions. If you have any doubt, you may ask in the tomorrow's class. The class overs now. Okay.